Hi children, welcome to my YouTube channel. This is the first video of the topic series Moments. What is moment? A door or a window is an example for a moment. We know that if you apply a force on a door or a window, it tends to rotate among the hinged point of that door or a window. So simply explain the moment, we can say moment of a force measure the turning effect of the force on a rigid body. I will give small experiment you to try. Go close to the door and try to push the door from its handle and from the point which is close to the hinged point. Which way is more easy? Obviously, if you experiment this, you will realize that moving the door, or what do you call that, pushing the door close to the handle is much easier than pushing it from a point close to the hinged point. Now we found a new term, that is a hinged point, or in another term we call it a pivot point. What do you mean by a hinged point or a pivot point? We know that you can fix an object from one point. In certain cases, if you fix it, it's totally not movable. You cannot pull into any kind of a direction, or it's not rotatable. Certain fixing techniques are there. You cannot move it vertically or horizontally, but it's free to move at like a circle. It's moved to rotate. That kind of a point is called a hinged. Then, as I mentioned you before, if you want to open or close the door, it's very easy to push from the handle rather than that pushing it from a point close to the hinged point. Therefore, the moment depends on the distance to the hinge. Then I will come up with another example. Suppose that a child like age of 1 or 1.5 or 2 like is trying to open or close a door. Would it be easier for him to do it? Obviously, it's very hard for him to open or close the door. What is the reason? Because the reason is that the force he or she apply is pretty small. But if I ask you to do it, you would be easily open or close a door. That means another significant effect for the moment. The second fact is the force. Therefore, simply we can say the moment is equals to the force into perpendicular length from pivot point to the force of action. That is the simplest definition of the moment. Simply we can say moment is force into distance or displacement. When you calculate the moment, we have to consider about two facts. The first fact is the magnitude of the moment. That means how large is the moment. The second fact is direction of the moment. We know that if you open the door, it rotates into one direction. If you close the door, it closes to another direction. So therefore, it can close clockwise or anti-clockwise. That means when you consider the moment around a point, we have to consider its magnitude and as well as its direction, whether it's clockwise or anti-clockwise. Okay children, now let's try to calculate the moment due to the force of 6 Newton around the point P. Right. According to the formula, the moment is force into distance, or the shortest distance from pivot point to the force. So you can understand the force applied here is 6 newtons and the shortest distance or the perpendicular distance from force to the pivot point P is 3. Therefore, you can work out the moment as 6 Newton into 3 meters, answer is 18 Newton meters. Then as I mentioned, we have to identify the direction, whether it's clockwise or anti-clockwise. I will teach you an easier method to identify the direction. First, take your pen and hold the book from the point P. Keep your pen on point P and hold it. Then try to push your book or the piece of paper in a direction you apply the force mentioned in the question. Right. Then see whether in which way it tends to rotate, whether it's rotate in a direction of a clockwise or anti-clockwise. According to this problem, if you hold your book from point P and if you apply a force of 6 newtons, it tends to rotate anti-clockwise. Therefore, the direction of this moment in this question is anti-clockwise 18 Newton meters. In this example, if you want to find the moment around point P, the force is 3 newtons and the perpendicular distance from that force to P is 2 meters. Therefore, you can say the moment is 3 newtons into 2 meters, that is 6 Newton meters. Now we need to find the direction. How to find the direction? As I mentioned you in the previous question, keep your pen, hold your book from the point P. Then apply a force of in a direction of 3 newtons, which way it tends to slide or rotate. You can understand that it tends to rotate in a direction of clockwise. Therefore, the moment is 6 Newton meters at a direction of clockwise. This is another important question. Here, the force is 5 Newton and you can understand that the force 5 Newton is traveling through the point P. So if you extend that force, it travels through P. For example, you are applying a force toward the direction of the thickness of the door. So try to push a force towards the hinge, toward the thickness of the door. So what happened? The door will move into any of the direction? No. So we can understand that here the force is 5 newtons but perpendicular distance is 0. Therefore, the moment would be 0 Newton meters. Therefore, you have to understand that if any force travels to the pivot point, it won't generate any kind of moment. So, answer is 0 Newton meters. Since this is 0, nothing to worry about whether it travel from clockwise or anti-clockwise. There is no such direction we can explain for this kind of a question. This is another important question where most of the students struggle to do. Right. Here there is a force of 12 Newton and it has marked a distance of 8, but the distance 8 is not the perpendicular for the force 12 Newtons. So you can understand according to this diagram, the perpendicular from point P to 12 Newton is the dotted line. Then there are two methods we can use. You can use any method you prefer to do it. Then I will teach you the first method and second method in the next slide. Right. Method 1. First of all, identify the perpendicular distance, that is PM, from point P to force of 12 Newton. So you can see, if you consider this right angle triangle, PM is the opposite and the distance 8 meters is given as that is the adjacent. So you can say opposite over adjacent is equals to sine value of it. Then you can say PM divided by 8, look carefully, PM divided by 8 is sine 35. With that you can say PM is equals to 8 sine 35. That value is 4.59. That means the perpendicular distance is 4.59 and the distance is 12. Therefore, your final answer is 55.06 Newton meters clockwise. Same technique apply. You keep your pen at point P and try to apply a force of 12 Newton in a direction of 12 Newton. There you can understand that it rotates clockwise. So, the force is 55.06 Newton meters clockwise. The second method to do this question is take this 12 Newton and consider the components of that 12 Newton. So if you take the components of 12 Newton towards the angle of 35, that is 12 cos 35. Perpendicular component is 12 sine 35. Then we can say this 12 sine 35 is perpendicular to point P. Then we can say 12 sine 35 into 8 meters. That means you can say 12 sine 35 is exactly perpendicular to this 8 meters. Therefore, you can write 12 sine 35 into 8. That is, you will obtain the answer as 55.06 Newton meters clockwise. Then what about this 12 cos 35 component? Now see whether this 12 cos 35 line is exactly traveling through P. Then what happened to that component? So we already knew that if a force is traveling through the pivot point, that component, that moment due to that force would be 0. So therefore no need of considering that 12 cos 35 component. If you feel like this technique is hard, you can use the previous technique, because from my personal experience I know most of the students are little bit confusing of using this technique. So if you feel like this is hard, use the first method to do this question. In this example, we need to find the moment around point P. So to work out this question, we don't know any kind of a perpendicular distance from point P to force 4 Newton. I will do a small construction in a way of getting the perpendicular distance. Therefore, the perpendicular distance would be D. Then consider this triangle. It's a right angle triangle where the D is the opposite and the given length 5 meters is the hypotenuse. Therefore, you can say sine 30 is equals to D over 5. With that, you can find the distance D as 2.5 meters. Then you can apply to the formula m is equals to F into D. Moment is equal to force into perpendicular distance. Force is 4 newtons and the distance is 2.5 meters. With that, you can say 10 Newton meters. The direction is anti-clockwise. The way of identify the direction, I think you would already know. In this question, we need to identify a perpendicular distance from point P to force 9.5 newtons. The distance given here is 2.8 meters is not the perpendicular distance. So you can mark the perpendicular distance D. With that, you can say D is the adjacent for this given angle and 2.8 is the hypotenuse. Therefore, you can say adjacent divided by hypotenuse is cos theta. The value is 60. Then you can say cos 60 equals to D over 2.8. With that, you will obtain the answer for D is 1.4 meters. With that, you can say moment is equals to force into shortest distance or the perpendicular distance 9.5 into 1.4. You will obtain the answer as 13.3. Then you can understand that this is a clockwise moment. This is another important question. Here the force is 8 Newton and the given length is 6.2 meters and we need to find the shortest distance. So make a small extension of 8 Newton and from point P draw a perpendicular. Therefore the perpendicular distance should be D. To find the perpendicular distance D, we need to find the unknown angle. Here the given angle is the obtuse angle. We need to find the related acute angle for that. How do you find that acute angle? You can subtract 137, the obtuse angle, out of the complementary angle 180. So with that you can say the acute angle related to this question is 43. Then we can say opposite upon hypotenuse is equals to sine theta. Therefore you can say D divided by 6.2 is equals to sine 43. That 43 came from 180 minus 137. With that you can say D is equals to 4.23. Then you can apply to the formula moment is equal to force into shortest distance of the perpendicular distance. 18 to 4.23, that is 33.83 Newton meters. This is anti-clockwise. In this question, the diagram shows a sign hanging from a wooden beam. The sign has a mass of 4 kilograms. So to find the moments, we need its weight. So we know that weight is equals to mass into gravity. Calculate the moment of the weight of the mass about P and about Q. So there are two different questions are there. With that, if you work out, you can understand that the weight is 4 into 9.8, that is 39.2. If you consider from P, the force is 39.2 and the distance is 8 meters. Therefore, you can work out the moment is 39.2 into 8, that is 313.6 Newton meters, that is clockwise. Then if you consider from point Q, what is the distance, shortest distance or the perpendicular distance to the force of 39.2? The total length is 12 meters. Out of 12 meters, if you remove 8, you will obtain the length of 4 meters. Therefore, you can calculate the weight as we can calculate the moment as 39.2, already found the weight, into 4 meters, that is 156.8 Newton meters. This is anti-clockwise. Remember that when you consider the moment, identifying the direction as well as magnitude would be very important. In this topic, we have discussed about the basic principle of moment and the related basic questions involved with moment. Hope you have understood the contents in this video. If you have any doubts, please put into the comment section, and if you like this video, put a big thumbs up and share this video with your friends. To see more educational videos, please subscribe my channel and click on the bell icon. See you from next videos.